everyone coming in, and it's 3:30, so I'd like to start. First of all, thanks for coming. Thanks for joining this session on modularity in the cloud. It's an especially exciting topic. At least I believe it's an especially exciting topic in these times because as applications increase and get larger, the issue of modularity in code bases becomes much more important to get a maintainable and understandable system. And on the other hand, that's design time, that's coding time. On the other hand, we have completely new deployment environments with the cloud. And it turns out that you can use these two together, these two developments, and get really nice properties. And I hope to show that in this session. And I'm going to do that a bit by providing some theory of modularity, but mostly it will be based on real-life experiences we've had with a system that we're building. So it already says it's a case study as well. So the plan is for me to start with an introduction of this system, because you need to know what it is before you can know how it is built. And after that, we'll turn to modularity, a little bit from the theoretical perspective, and then quickly onto how we applied it in the system and how we applied it towards a system that is also deployable in the cloud. First of all, let me introduce myself. Also, there were two names on this presentation. Unfortunately, my co-worker Jan Willem couldn't make it due to a family emergency, so I will be filling in for him. My name is Sander Mak. I work for Luminous Technologies in the Netherlands. We're a company who are building products for the Dutch market mainly. We're really into modular architectures, doing mostly Java development, but also sometimes different JVM languages. Anyway, if you want to read about things that I find interesting, you can also check out my blog at branchandbound.net. And if you think you've got some interesting comments to give on my presentation, you can also contact me on Twitter. So, enough about me. Let's move on to the actual case study. And I will start by introducing to you the system called Pulson. And Pulson is an educational system that we developed for the Dutch high school market, secondary schools in the Netherlands. And the idea behind Pulson is that up until now, most schools all work the same. You have a teacher, you as a student have a book, you all read the same book, you all do the same exercises, you all get the same explanations from the teachers, and that's it. That should be enough, right? Well, not really, because in practice it turns out people are different, and some people learn better by reading, and some people learn better by listening to someone explain it to them, and some people learn better by doing exercises. So yeah, it turns out there are lots of different types of students and lots of different profiles among students. And the educational system is not really fit for that yet. But we hope, with our Pulson system, to create a system that enables students to learn at their own pace and in their own preferred way. So that's a bit of the background about this system. As I said, it's currently used by some high schools in the Netherlands. We're in the pilot phase, and we hope to start after this summer an actual production phase. But it's not just limited to the Netherlands as far as we are concerned. These principles apply worldwide, so why not have customers worldwide? And we're working on that as well, but currently our main playing ground is the Netherlands. So, what were the requirements that we started out with when this Pulson system was being proposed and was being thought out by people? Well, the first thing is that it's just something that needs to be accessible anywhere, anytime, by anyone. I've heard that before, of course, but in our case it's mostly tablets that are being used in the classroom. So it might be that a school buys iPads for students, or it might be that they say, okay, you can buy your own, so bring your own device. So we have to support everything ranging from iPads to Android devices to Windows 8 devices to Chromebooks, you name it. Fortunately, those are all pretty modern devices, so no Internet Explorer 7 or something. That's really out of scope for us. But that's the scope of the requirement. So you already heard here with these requirements that really native applications are a bit, it will be too cumbersome to do this for all the platforms. So it will be a web application. Now, I told you that schools are currently working mostly in the same way, the book, the teacher, and the explanation, and that we have a system that will turn it around, that will offer many ways to absorb content, to learn in your own way. And it turns out that schools really like this, but for different reasons. So not every school has the same ideas about how to use our system. So that means there needs to be a lot of flexibility, especially when you're starting out in the system, to support all kinds of different views on what good learning is. So that means that we have several components in the system, and they need to be able to mix and match that to match the external wishes of a school. Scalability, pretty important. There's lots of students in the Netherlands only, and if you're thinking worldwide, well, there's lots of potential for users there. So that's something that we had to take into account from the start. And another thing is that since we will host this software for schools, so to say it's a software as a service solution, we need to make our own lives easier by making it easy to upgrade the software and maintain different configurations. And well, I think you can get the idea a little bit. And that can really be a pain if you have like 40 customers who all have different, slightly different configurations of components, etc., deployed on the same infrastructure, but still it's something that you need to manage. So those were the requirements, and now I can show you at least the current end result. This is one screenshot. This is the sort of opening page that you get as a student when you log in, and you can see it's sort of a page which contains little gadgets, we call them, and each of these blocks you can click on and you get a different screen with different functionality. It's sort of like your home screen on your phone with little apps on them, and you can even add your own apps. And it's a pretty dynamic screen in the sense that, of course, every student learns something different, has different courses, etc. So that's all in here. It's important to remember it's heavily personalized, not only for the students, but also per school, what kind of apps are available in this home screen. Then, of course, when you open, for example, a German course, in this case, you will get to the actual content. And it's a bit off screen here, but at the far left, you have what we call learning objectives. So these are the actual goals that you want to achieve. The other way, please. Yeah. Okay, so these are the objectives that you want to achieve. You want to learn something about the German language, for example. And if you click on one of these objectives, you get lots of different kinds of learning objects, and that's the actual content that you can choose from to achieve this objective, to learn it. And any of these blocks may be either exercises, or it may be a video with explanations, or it may be just textual explanation. And the nice thing about Pulse on this is that it learns what works for you. So if it sees that you are progressing really quickly through the learning objectives by seeing videos, for example, it will try to steer you towards these types of content. And it tries to learn how you learn. And that's pretty important part of the system, and we call it adaptive recommended learning. And so on one hand, you have this system that recommends to students particular ways to achieve learning objectives. On the other hand, you of course have the teachers who want to see how their students are doing. And for this, we do a lot of profiling of all the actions that are happening in the system, that all the clicks the student makes, everything is tracked. And we have many visualizations that help the teacher also to gain insight into his class. How are they doing? So this is just one example. It's a sort of timeline, and these circles, they grow, and they move about the timeline, and this tells the teacher something about how his class is doing with regards to the current course. So this is all just to give you an impression of some of the functionality of Perlzone. And of course it wasn't always like that. We had to start from nothing. And the big question is, of course, how are you going to build software? Well, nobody can tell you what exactly to build. I mean, we do it all the time, right, as software developers, right? Yeah, I mean, so what will your answer be? How do you do this? You ask, and you get some kind of vague answer, yeah, something like this. Maybe this, maybe that. So, prototype, yeah, that's a good thing. Agile is, of course, something as kind of a Scrum process or something that you might want to do. And actually, that's what we did in the beginning. And we started with very short iterations, get quick feedback, and try to steer in the right direction. But that's only just one part of the aspect of building software that you don't really know what's going to be. I mean, process is important, and Scrum, it has worked for us, but it's just one aspect. And the other aspect is the software itself. And if you start with nothing, and you start building, and you start changing things, then, well, there's not really a problem. But once you get to 10, 20,000 lines of code, things tend to get a bit hairy if you don't really know what you're doing anymore. So you need to do something else besides the process to your actual software to enable high feature tree, to enable experimentation, to enable quick changes and quick changes in direction. And that's where we believe that software modularity plays a very big role. So what is software modularity? Well, at a very high level you could just say, okay, it's just picking a clever way to chop up your software into pieces. Okay, well, that doesn't help very much, but it is essentially right. And why do you want to do that? You want to do that in such a way that each of these pieces, each of these modules, are really, very independent parts of your system. And independent means often what we call low coupling between modules and high internal cohesion. So a module should do one thing, it should do it very well. And that's of course also the Unix philosophy of the small command line tools that compose together to do great things, but in and of themselves they're really dumb and really small. And that's good, because that makes them maintainable, and that makes them understandable, and that makes them, real good building blocks. So you want to isolate changes. And one nice example of this is that, for example, when we started out, we had a semantic database underneath Perlzone, which is a triple store, RDF kind of thing. And it seemed like a good idea, but it really wasn't. And that was, after a few months, we built on it, and we decided that we needed something else for our storage needs. So what if we would have passed all these abstractions that are living at the storage layer to other parts of the system? It will ripple throughout the whole system to create, if we wanted to change that, then it will create enormous challenges, enormous effort will be needed to change just the data store. But fortunately, we had a modularized code base, and the semantic database was really pushed down into this single storage module. And the funny thing was that that was the only module that we had to swap out in our system. And we had to swap in, or in our case we chose MongoDB. But all our abstractions were really separated and modularized. And I'm going to show you how we did that, but that's just the gist of it. And modularity means chopping up your code base and doing it at the right points in your code base. And of course, the trick is to find these points, and you need experience for that, and you need to think really hard about what are the responsibilities of a module, etc., etc. So, what does this mean in practice for our Java programs? Well, it means that we keep doing what we always did. We do object-oriented programming, that's at the lowest level. And we know about implementation hiding, we know about the single responsibility principle, all very good things. But on the other hand, that's not just enough. It turns out that if you do proper OO programming, you can still create a pretty big ball of spaghetti, so to say, in terms of dependencies between classes and in your whole system. So also at a level slightly above just OO design and class design, you need to think of modularity. You need to apply it rigorously. One way to start with it is to program to interfaces. So define sort of services in your application and decouple the implementation from the actual interface you're talking to. So you can easily swap out your implementation. For example, if you don't want your triple store, your RDF semantic database anymore, but you want MongoDB, well, fine. But your interface should be the same because you're still storing the same kind of data. You're just doing it in a different subsystem. Another way of finding the module boundaries in your system might be to look at the rate of change that certain parts of your code have. It turns out that front-end code, of course, changes very often because everybody has to have a say about the color of this or that and the positioning of the object, etc. So it might be a really good idea to modularize, to separate this really from other parts of your system. And we already do that to a large extent, of course. At the other extreme, and if you talk about modularity at a level of systems, then most often we think about things like service-oriented architecture, right? You have your systems and you define responsibilities, and all the same rules and principles still apply, just at a level of actual software systems, not just classes. The modularity that I'm talking about today lives in between this OO and this class design and the service-oriented architecture, so somewhere here. And it turns out that there's not really anything standardized for that. At least not something that's widely popular and widely applied. There is OSGi and OSGi modules, and that's actually what we use in our systems. It's not really a Java specification, but it is a de facto standard. It's already around for 10, 15 years or something, so it's not something that you just cannot trust or that is really new. So what do modules look like in OSGi? Well, actually a module is just a jar, but not just a jar, but a jar extended with some metadata. Essentially what you can what you can add to a jar is, okay, I contain these packages. By default, OSGi says all these packages and classes are not visible to outside users of this jar. If you want people to use things inside this jar, you have to explicitly export these packages. And you see that here, that you also can declare imports on different packages, or different modules, and this is also at a package level. And this way you can neatly hide your implementation classes inside the jar and only expose your public classes. And OSGi not only enforces this at design time and at coding time, like you could also do with Java visibility modifiers, for example, although these are not really strictly enforced. If you really want around them, you can get around them. And OSGi enforces this by having a separate class loader for modules, and I'm not going to go into detail, but it works very well. So this gives you a very nice way to express dependencies between modules and to hide implementation details inside modules, and only expose what you want to expose to other parts of the system. Now you might be thinking, okay, that's all very nice and all very well, but if I expose an interface through an export in an OSGi bundle and the implementation is hidden, and I want to use some instantiation of this interface in a different bundle, which does not have access to my implementation because it's hidden, how do I do that? How do I create an instance? Well, the answer to that is quite simple. You don't. You cannot get. You cannot do a new of my implementation class. So there has to be another way. There has to be another way to work around this. Unfortunately, OSGi also provides something that helps for this situation. There's not only the possibility to create modules and express dependency between modules in OSGi. There's also the notion of having services. And OSGi provides a service registry, and a module can, at time that it is started, and again, I'm not going to go very deep into the details of OSGi, but OSGi also adds a life cycle to bundles, so they can be started, they can be stopped, they can be inactive, etc. But when a bundle is started in the OSGi runtime, then you can also say, okay, I want to register a service in service registry, and I want to have it under the interface name registered in this registry. And then if a module B wants to use a service that conforms to this interface, then it can look it up in the service registry, and it will get the implementation. And the implementation, of course, lives in the module A and is hidden. So module B does not directly depend on it because it doesn't instantiate it. It doesn't use a constructor to create the implementation, but it will get it from the service registry. Now, of course, this is not groundbreaking, and this is not new. This is done at many levels. This is also, if you think about SOA, then this is also a pattern that is used very often. But in this case, the service registry is just purely something that lives inside a single JVM. So you will get a direct in JVM reference. There will be no remoting or marshalling or whatever. It will be a Java call in the end when you use methods on this interface. So the overhead, there is some overhead, but it's not really very big. Are there any questions, by the way, so far about this little primer on OSGi services? Excuse me?
Is this module deployed in one JVM or different?
Okay, the question is this module deployed in a single JVM or could it be multiple JVMs? It has to be in a single JVM for the normal OSGi service registry to work. There's also a concept of remote services, but we don't use it. You could use it, but that's not what I'm trying to picture. Okay. So if there are no further questions on this OSGi in a nutshell in 5 minutes introduction, then I think it would be nice to have a look at the actual architecture of Pilzone and how we used the OSGi module system and the OSGi services layer to actually get the flexibility that we needed to create the system and to deploy it for many different customers and many different configurations. So, of course, this is quite a typical layered architecture. And at the top, you see that our view layer, what is the web app. We chose to create an HTML5 and JavaScript application. So there's no server-side templating or anything going on. It's all HTML and JavaScript. Actually, we use AngularJS to build the whole client side. And this is a stateless layer. So there might be some transient state when there's things happening in the client, but all state is actually in the end pushed down to data stores. The rest of the layers do not contain any state either. So all the services, all the business services, all the REST endpoints are all stateless. And actually, each of these layers consists of OSGi bundles. So even the HTML and the JavaScript are bundled as just resources in a jar and are chopped up into different modules according to their goals and combined if they have high cohesion and try to have as less coupling as possible to each other. So we have little bits of user interface. These are combined into this dashboard that I've shown before. And each of these little parts of the UI talk to RESTful web services. And again, these are all separated according to their goals and according to their own needs into little bundles that each expose one or a few REST endpoints that pertain to the single functional area of the system. There's no business logic in these RESTful endpoints. It's just creating the endpoints, doing the marshalling and unmarshalling of JSON to communicate with the user interface. Only below this, when we get to the OSGi services that we have in the system, we get some actual business logic. It all runs on top of Apache Felix, which is an OSGi runtime container. There's no particular reason that it has to run on Apache Felix. There are many other options as well. We like it because we have some committers of Apache Felix on our team, so that helps. But there are lots of good options there. And in the end, all storage is currently done on Mongo, but well, as I said, it used to be a different data store, and it might be another one in the future, we don't know, but currently it's Mongo. And Amazon S3 is used for all static assets of all the learning content. Then there's this unexplained blog called Andatu, and it's even on my shirt and everything, so that must be something as well. It is. Andatu is an open source cloud innovation platform, we call it, and it actually contains some building blocks, some technical building blocks that you can use in web building OSGi-based enterprise and web applications. I'll get to Andatu a bit later. Now I'd like to move on and decompose the picture that we saw in the previous slide a bit more and look at how it actually works when you look at the individual bundles and modules. So, for example, if you open a course, we have this gadget mechanism, right? So you click on this block for the German course and it pops up, and the UI that you get is served out of the course.gadget bundle.
Sorry, what is S3?
Amazon S3. It's a store for binaries, so to say. It's a cloud-based file system. Yeah. So this course gadget needs to know in what sequence it has to display all the course materials to the user, and it talks to this REST endpoint, which in itself is also an OSGi bundle, which contains the REST endpoint and knows how to marshal, demarshal, and how to communicate with the course gadget. When we get below there, this content sequencer uses a Mongo bundle, which contains all the details about how to communicate with Mongo, and it uses the storage bundle to retrieve the pictures and other kinds of videos and other kinds of static content from Amazon S3. So if we decide to switch to a different platform, a different cloud provider, Azure, I don't know, we would have to swap out, for example, this content storage module for something that implements Microsoft Azure specific one, but we could leave all the rest untouched. And that's the goal, of course, of modularity, to isolate changes, to make systems maintainable and understandable, and in our case also very flexible. Now, this is more or less a static view of how these bundles layer and these modules layer. If you put in the interactions, you see that the gadget is not necessarily restricted to only talk to this content sequencer endpoint. As I said in the beginning of the presentation, we also do a lot of profiling of all the clicks and all the actions that happen in the system. And for that, this course gadget also talks, for example, to the profiling endpoint. And of course, since these are all just REST endpoints, we can do HTTP calls, and there's no problem there. Of course, that's a dependency between modules that's not managed by OSGi, because OSGi only cares about Java dependencies, not about actual runtime HTTP calls that are happening. So it's something that you have to keep in mind when you're working on a system. That will not be enforced by the OSGi runtime. But anyway, the content sequencer uses an engine, and to sequence content, you have to know what the student did before. Because as I said, we are an adaptive system. We're not just doing fixed book order sequences of content. No, we want to learn what works best for the student. So the content sequencer engine uses the MongoDB profiling data, but also, of course, this REST endpoint that puts data into this profiling system. So you see that there's reuse of bundles at different layers in the system as well. Now, you've heard me talking about bundles, 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 bundles. So you probably at this point in a typical deployment for a school, there are about 190 OSGi bundles comprising the whole system. Those are not all bundles that are written by us. As you can see, there are 120 that are specific Pilsen bundles that we've written. The others, where do they come from? Well, they're just libraries that we use. So, the same way that you would have jars in your web and lib, we also have we also use libraries. For example, we use the MongoDB Java driver, of course, because otherwise it would be quite hard to talk to Mongo, which is just a jar, which actually already is an OSGi bundle when you download it, so that's pretty nice. You can easily use this. So about 70 of these bundles are actually generic usable components, and 120 of the bundles are Pilsen specific. So does it mean that when we open our development environment that we get 120 projects beneath each other? Well, fortunately not, because an OSGi bundle with the tooling that we use, which is being details, doesn't have to map directly to a single Eclipse project or a single project in your version control. A single project can emit multiple bundles. For example, what we often have is that a single Eclipse project contains an API bundle, so a bundle that defines the interface of everything that's happening, and one or more implementation bundles that cover parts of the functional domain that this project is for. So, all in all, we do have more projects in our workspace in Eclipse than the typical enterprise development, I guess, but not 120, fortunately. So, these external dependencies that I talked about, they're not just other jars, they're also bundles coming from the Andatu cloud platform. It is an open source project that we started when we found out that, okay, we want the benefits of OSGi, of an OSGi based architecture, of a modular architecture. But when you are building on top of an OSGi runtime container, you're not in the Java EE world anymore. And on the one hand, that might be a relief for some, but on the other hand, there's all kinds of nice things in Java EE, JAX and REST, JPA, other things. I mean, it's not there for nothing. And you can do really nice things with it. And when you start with OSGi, you practically have a clean slate that you're building on. And Andatu tries to fill this void. Andatu contains several technical components that you can reuse in your OSGi-based enterprise application. For example, it contains a JAX-RS implementation, which we heavily use in Pilsen. It contains a MongoDB implementation, which not only creates a nice bundle that you can use in OSGi, but also a service on top of this bundle, an OSGi service, in which you can very easily obtain a managed connection to a MongoDB database. Well, I don't have enough time to walk through all of them. If you're interested in this, at andatu.org, you can find them all. And this will only grow the more projects we are building in this architecture. And for example, if you look at the Andatu MongoDB component, why did we choose MongoDB? Well, most of our data is already in JSON and in REST form. Because of the choice that we made for HTML5 and JavaScript. So it makes sense to store this in a database that's natively supported. The profiling that we have generates lots of data, lots of data that we even don't know what to do with yet, but we will. But we need to support the scalability characteristics that come with this profiling data. And we also need ad hoc queries. So lots of NoSQL stores need to think about what kind of queries you do up front. We cannot do that, so Mongo offers ad hoc queries, a bit like you can do in a SQL database. So that's one of the reasons that we created this component. Another interesting aspect, I believe, in Bullseye is this whole modularized UI. So often web frameworks and UI toolkits, they're not really ready to be modularized. Often there's a central configuration. For example, in JSF you have the faces config, or there's really an assumption that at one point everything comes together, and that's where your UI is built. Well, for us, not so much. I mean, like I said, it's a very dynamic system. Each school can have different applications in their home screen, so we really need some flexibility there. So the question we ask ourselves is, okay, how can you separate your UI? How can you modularize it in the same way that you do with your business logic and your lower layers? Well, for that we use an open social implementation, which has the concept of gadgets. And these gadgets are these things that we had on the home screen that you can open. That has worked very well for us. I recognize that it's not always appropriate for every application to have this sort of home screen-like approach in which you can open several sub-applications. So if you have other needs in your UI, this is just an area where you will have to do a lot of research and a lot of work to get a truly modular UI. But I've seen people doing it with Spring and C, for example, as well in an OSGi context. So it is possible, but you will have to work for it. Well, that's about all I wanted to say about how we approach the modular architecture, the modular design, using OSGi. Now I'd like to move on to the cloud part, the deployment part. Like I said, currently we are deployed onto Amazon, the Amazon cloud. We're not particularly tied to it. It could be any cloud that offers us virtualized Linux machines. And we'll see in a bit why we can move so easily to other clouds as well. But this is a picture of our current deployment architecture. So what you see is that for each school we have a separate cluster that we can spin up, which contains our application. Because it is stateless, we can easily put a load balancer, in this case Amazon Elastic Load Balancer, in front of it, and just spin up as many nodes that we use. Mongo also runs underneath this in a cluster mode. Actually, this picture is not completely accurate because even though we have a cluster of Bullseye nodes per school, we currently only have a single cluster of MongoDB for all the schools that we serve. Because the load is so easily handled by this cluster of 3 Mongo instances that we just really don't have the need yet, but we could really split it up if necessary further. This is all nice, of course, but if you have a load balancer, then of course the next question is, how do you know how many nodes you need to put behind this load balancer? And then you can then get into things like autoscaling. And in our case, the loads on the system do vary, but they're quite predictable, the variations. Because in the morning, students get into school, they grab their tablets and they start working. And about 4 o'clock, 5 o'clock, you see it going down, 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 down. And in the evenings, somehow students aren't really active. I don't know why. Anyway, so you need to have enough capacity to handle the peaks and the daily load from say 8 a.m. to 4 or 5 p.m. But on the other hand, we don't want to pay for idling service as well after that. So how do we achieve this using autoscaling? Well, like I said, we have this cluster in a school, and when the day starts and during the night, this load balancer is still there. But we only have one single small node from Amazon behind it. And why is the load balancer still there? Well, if we're going to change whatever is here, then we need some continuity. And since you cannot change the size of a node at Amazon, you cannot just say, okay, make this small node, make it big. You need to stop it, and you need to start a new one that has more memory and more CPU. And then, well, if you want zero downtime deployments, then you need to do something smarter. So we always have a load balancer in front. And early in the morning, when the small node is still running, using Amazon Autoscaling, we start up 2 larger nodes in addition to the small node. And these register themselves with the load balancer, and Amazon, the load balancer automatically takes care of spreading the load. And then, of course, when students are tired at the end of the day, then these nodes are stopped, and we save considerably on our Amazon hosting bill. So this is autoscaling using timed triggers, because we know how the load is going to be throughout the day. If you have a system where you don't know, well, that's not a problem either, because with Amazon Autoscaling you can also have load-based triggers. It's just a matter of configuration, and in the end it's just about picking the right thresholds, picking the right triggers, and Amazon will do the rest for you. Now, with all these nodes coming up and going down, one question you should ask yourself is, of course, how do we install our software on the nodes? Because Amazon runs images, which are just, well, when you take the default ones, you just plain Linux images. And of course you could create your own image with our software installed on it, and then spin that image up with, well, when you have an upgrade to your software system, you create a new image. And as I said, we have many different configurations, so you would have to have many different images maintained in parallel. So that's not really something that's a scalable solution from a management point of view. So to solve this, we use a provisioning system called Apache ACE. Apache ACE is a general software provisioning solution. It's built using OSGi, but you can use it for other software than OSGi-based software as well. But in our case, we deploy our OSGi-based system through ACE to the actual service that we have at Amazon. We create a release, which means that we create 190 bundles, like I said, that belong together, that create a running system. And we provide it to ACE, and ACE automatically takes care of distributing this to all the nodes that are managed by ACE. And one nice thing about ACE is that if you have 190 bundles and that's your system, well, it's all very nice, but it's not something that you can pick up and really reason about. And ACE has the possibility to create aggregations of bundles into features, and features can be aggregated into distributions. So we start out at the left-hand side with these 190 OSGi bundles. We create several features that describe functional areas of the system, and we create a single distribution that we target to the servers that are at the far right that are known to ACE. So in this case there's only one server, but in practice there are many. So how does it work? Well, like we saw, Amazon Autoscaling takes care of starting and stopping nodes. A node is just a Linux image containing a clean Java JDK, and it contains a clean, empty OSGi runtime container with only one additional bundle, and that is the ACE management runtime agent. And this node comes up, and the OSGi container restarted, and this management agent says, hey, okay, I'm alive, I'm going to register myself with Apache ACE. And it says to ACE, okay, tell me, what do I need? And then Apache ACE knows which distribution needs to go to which server, and it sends the bundles. And this is the third step, the provisioning of the deployment package. And after that's done, then this node can register itself with the load balancer because it's fully operational. And it has all the software it needs to function. The nice thing is that this doesn't just work for new installs of our system. It also works for fixes, upgrades, bot fixes, that kind of thing. And the nice thing about the modular architecture is that if you change a single line of code, it will only lead to a single new bundle in which this line of code was contained. Which also means that you only have to upload this single bundle to Apache ACE, and Apache ACE will figure out, okay, the previous version of this bundle was used in these and these features, which were in these and these distributions, which are currently on these servers, and it sends this single bundle, a single new version, to this server, and your system is automatically up and running. Since OSGi is a dynamic runtime, you can just swap in a new bundle in place of an old bundle which had a burden. So it's also really a way to do incremental deployments rather than just having a 200 megabyte WAR file and needing to bring down WebSphere and etc. etc. We've all seen, I guess. Question?
Sorry, question. How many times does it take to deploy a fresh bundle?
The question is how much time does it take to deploy a
new single bundle?
Yeah, it can be sub-second. I mean, it depends on the size of the bundle, but typically your jar will be something like 100 kilobytes or something. That's even big. And because all the communication between ACE and nodes is internal on the Amazon network, it can be really quick. And OSGi, starting and stopping a bundle is also near instant. So
you just push the fix through the ACE and it's already there?
Yes. Yeah. So this was. Oh, there's one more question.
For each school, you have your its own configuration. Yeah. So
Yes.
your Apache ACE is configured for each school. It has its own configuration, which bundle to take and to which feature. Yes. Am I correct?
Yeah. So the question or the remark is that different schools have different configurations. This also means that you have different distributions containing different combinations of bundles.
But Apache ACE takes care of this, and that's the only difference. Or you have to manage your configuration in Apache ACE and somewhere else.
No, you can do it all in Apache ACE.
Oh.
Yeah. So we're kind of getting to the end of this. This was the case study, and of course it's a single data point. I mean, it's successful for us, but it doesn't mean it has to be successful for any kind of application. But we really do believe that this architecture fits most modern web applications. It can work in the cloud because we're doing it. It could also work in a different environment because Apache ACE doesn't care whether it targets a Amazon node or whether it targets a physical machine, or as long as there's a management agent running, ACE is happy. So it can work in the cloud, but it's not a hard requirement. And the tooling and the frameworks around OSGi are starting to get to the point that they're actually usable by developers like you and me. And with the tools, I'm mainly referring to the Eclipse plugin B&D tools, which is a very, very practical way to develop OSGi bundles. But also things like the ACE provisioning agent and the whole combination of things. And of course, the open source project that we really care about, Undatum.org, which contains all these components that you can use directly in your OSGi environment and get some of the nice things that you would otherwise have to miss or would have to invent for yourself in an OSGi context. And with that, I'd like to leave you with some links. ACE.apache.org, it's a top-level project. Undatum.org to see what it's all about, and the B&D tools plugin at the lower left, and my Twitter handle if you'd like to comment and talk a little further after this, and I'll be there still taking questions as well. And for now, I'd like to thank you guys for listening. I think we have 3 minutes left, so if there are any questions in general? Yeah, the user interface is also kept in bundles. Yeah. Okay, so the question is, what is happening? Yeah. So the question is, how does this bundle with HTML and JavaScript get served? Because it's just a jar with resources, that's right. We use the so-called whiteboard pattern in OSGi to register these services with an HTTP service, OSGi, and it picks up these bundles and sees them and says, okay, I will serve the files that are inside this bundle. And when you request the URL, you can just get the HTML and JavaScript. Actually, that's also a part of Adato, if I recall correctly. So you can also use this way of serving static resources. It's served by the OSGi HTTP service, yes. So there's no Tomcat or no other server container involved. Yeah. Okay, any questions? Gentleman in front. Yes, using BND tools, you can have one Eclipse project which emits multiple OSGi bundles. Yes. Sorry, I didn't get the question.
How is
the tool to create these bundles is the BND tools plugin, and that under the covers uses the actual BND library. Another question? Okay, the question is, do we use CI server to upload the bundles to ACE? Currently, it's a manual action. But you could, of course, ACE also has a REST API, which you can talk to. So I can really imagine that going further, then we also would create a CI plugin or something that pushes bundles to ACE when they're succeeding in the build. Yeah, that's a possibility. Okay. Time's up, but I'll still be here until the next presentation begins, so feel free to come on. And thanks again.